We are on section 7.5, exponential and logarithmic equations and inequalities. I actually didn't choose any inequalities for this video just because they're so similar to the equations. So I went through and chose 3 equations that are all a little bit different, that use a little bit different methods, and I'm going to do the 3 of those on the video. So the first one is an equation, and there's a logarithm on each side, and those logarithms already have the same base. They are both base 2. So if this part of the equation, if they have that in common and those are already equal, then in order for the 2 sides to be equal in total, then the part after the logarithm would also have to be equal. So if this is already equal and you know the 2 sides are equivalent, then these also have to be equal. So you can set up a new equation without the logarithms and solve for x. So you can set the 7x plus 1 equal to the 2x, or the 2 minus x. Now it only works if both of the logs are equal, so they both have the same base. And now you have an algebra equation that you can solve. And x is equal to 1/8. The second type that I looked up had more than one log on the same side, and then it's equal to a number over here. So typically, when you have multiple logarithms, first thing you want to do is combine them into a single log. So these are from 7.4. You have 2 logs. They both have the same base. They're both base 10, and they're added together. So I can combine them into a single log base 10, and when I combine them, I multiply. When you combine addition, you multiply. That's the product property. So I'm going to multiply x by x plus 48. And that is equal to 2. So this I'm going to distribute, multiply the x in to simplify this. And I have log x times x is x squared, x times 48 is 48x. Once you have just one logarithm, in order to get rid of that, in order to have an equation that does not have that, you want to rewrite it in exponential form. Exponential form is the inverse of logarithms, and we practiced going back and forth. So remember there's a little base of 10 down there, and remember how we made the e? So you start with the 10, we're writing in exponential form now. You start with the 10, go around through the 2, and through to make your e. So the base is 10, go around, the exponent is 2, so you get 10 to the second equals, and then it's going to equal, instead of a number this time, it's going to equal all of this. X to the second plus 48x. 10 squared is 100. And now we have an x squared. It's a quadratic, which I know is all of your guys' favorite kind of equation to solve. In order to solve a quadratic, you need to have it equal to 0, so I'm going to subtract 100 from both sides. And you can now fall back on your flip chart. If you would rather use quadratic formula, you can use quadratic. I'm going to factor because it's faster for me. So 2 numbers that multiply to negative 100 and add to 48 are 50 and negative 2. If those are the factors, then the solutions are negative 50, negative 50 and positive 2. But we talked about how you can't take log, it's log of x up here. If x is negative 50, you can't take log of a negative number. So that means that solution is out, and you are left with x equals 2. The third and final kind that we are going to do today is when we have variables in the exponent. So if you remember on Tuesday when we went through the properties of logarithms, I told you that my very favorite is the power property, and that's the one that allows you to take an exponent and to pull it down in the front. But you can only do that if you have logarithms, and we do not. So the first thing that we need to do is we need to take the log of both sides. So you just write a log in front, and it's okay as long as you do it on both sides. So the power property now says that I can take those exponents, I can pull them down in front of the log and multiply. So I pull the x down in front on the left-hand side and get x times log of 1/4 equals the x minus 1, that whole thing is the exponent now. Pull that down in front, x minus 1 times log of 8. Now here's where you need to be a little bit careful. There's actually two ways to do it, but you're multiplying both of these, so I'm going to distribute the log 8. I'm going to multiply both of these by log of 8. So x times log of 8, and then -1 times log 8 is just negative log 8. So all of these logs, log with just a number, log just a number, log just a number, those are just going to be decimals. And use your calculator to go through, and you can do them all now if you'd like. You can change all of those. So you'd enter log of 1/4 in your calculator, and you get -0.602x. And this will help you see that it's just an algebra equation at this point. Log of 8 is 0.903x, and then minus 0.903. Log of 8 in your calculator is 0.903. We need to collect the x's on one side, so I'm going to move this one over to the left. And bring that one down. And then divide both sides by -1.505. Those cancel, and you get x is equal to 0.6.